Hi guys, there are several things that I wanted to explain, but it's gonna be too much for one video, so probably I will split into several series. Um, First of all, I will be honest, so since I'm explaining the things on the fly, it might be a little bit repetitive words and phrases that I will be using unconsciously, of course, while I'm talking. And other than that, since it would be nice to start from the beginning, let's say from the binary and from the really low level, from the computer science basics. But as I said, since I'm explaining on the fly, I am not quite well on explaining the things because I'm still learning myself and I don't know how to explain those things, to be honest. So that's why I start with the networking. So it's basically the um, the binary, and then the later things which comes after the binary, which is not the lowest level but a little bit higher than the lowest level. So probably it will be about networking stuff. As you have seen, I'm just taking this crash course about the computer science. So it basically starts with the lowest level, as I said earlier, with the binary, and then goes all the way up to the machine learning, artificial intelligence, and those sort of things, like general explanation of the things that we should be aware of. So it will not dive deep into those things, but the overall explanation for us. So as I have seen, the computer networks comes um, almost last part of the course, but I will be starting with the mm, with the networking, even though it's almost one of the last things from when it comes to computer science basics. But as I said earlier, I am not quite good at right now at explaining those things which comes before the networking, which are the things that about operating system, file systems, and I don't know, maybe circuits, data structures, and algorithms. I mean, I could understand, I explain about data structures and algorithms, but there are a lot, tons of them, and so and my current learning process is not focused on data structures and algorithms. But in the future, maybe I will be more focusing on explaining those things, but not right now. So. Uh, Other than that, we have CPU designs and instructions and programs, and what else? We have registers and CPUs and clock speed, those sort of things, as I said. But those are pretty interesting to find out. As I said, I'm still taking this course, and I will highly recommend for you too as well, because the content is really on the next level when it comes to the explaining the things, and with the visual animations, and with a really clear choice of words when it comes to delivering the concept to the users, to the learners. And yeah, um, so let's dive into it. So as I said, I do not have any presentation prepared, and as I said, I do not have any scripts that I'm reading from my screen. I will be just explaining the things on the fly, and making things up on the fly as well when it comes to the examples and the pictures. So I will be just, okay, let's start with the, for example, what is networking. And as I said, I will be just explaining things on the fly, and like finding slides dynamically. So and I hope we agreed on that. and let's dive into. So let's start with the networking. What is networking? According to the, let's say, Gemini AI, networking in general sense involves building and maintaining relationships to connect with others and access resources, information, and opportunities. It can be a valuable tool for career development and in finding unadvertised jobs. And okay, I think we missed the term because it is not about quite networking in terms of like people and people communicating and networking with each other. So it should be let's say what is networking in computer science rather than networking in general term. Yep. Sorry for wasting your time a bit so on that. Yeah, in computer science, networking is the field that deals with connecting computing devices to share data and resources. Okay, let's mark this sentence. As you have seen, networking is the field that deals with connecting computing devices to share the data and resources. As I have said, it's basically the idea of connecting a lot of computers with each other so they can share the data. For example, you are talking from one country to another country to your friends, let's say, and the two computers that you are talking from your computer and then your friend receiving and sending back to you, uh, the two computers that you guys have are not connected directly, because let's say in our world there are billions of computers and devices, mobile phones. So the big brain thing, the really clever idea of networking is to know when and to whom send or receive those messages, let's say, or data. I mean, when I say data, it could be anything. You could share the video, images, and text-based and audio-based messages, or anything that you could share with your friends in your um, daily life, or it could be gaming. So it's always the data. Yeah, will it's always all about the data that are changing, that are exchanging between people, between friends, between corporations, between companies, between countries, and from like individuals to massive users. So let's agree to the term that when I say data, uh, I mean everything that we can share, that we can see, that we can find on the internet can be counted as data, whether it could be image or audio, video, doesn't matter. It could be gaming or anything else that you can imagine on nowadays world. So back to our terms, the field that deals with connecting computing devices to share data and resources. So it involves the study of how these devices communicate and exchange information using protocols and technologies to facilitate this interaction. Okay, I just lost my way of thought, so I will be back reading on that. So it involves the study of how these devices communicate, okay, and exchange the information. So basically, what this sentence is stating in simple terms is that it basically saying that this networking in computer science uh, is the part of those computer science thing, which handles device communicate and exchange information. Basically, think of it as this. For example, as I said, two computers, and the networking part is the one who handles all those communications. So your message gets to exactly to your friend, and and your friend's message gets to exactly back to you. So networking basically handles those things. So it's like really important thing, because let's say in the case of postman, let's say you want to send a post or email, let's say post to your friend, but you of course want to um, of course you want your postman to send exactly your message exactly to your friend, because it's gonna be, if it's not the case, then it's gonna be probably the chaotic world where everything just works randomly. So what it means eventually is that networking is pretty much really important, important part of the computer science, which makes impossible without networking to have our nowadays innovation. And other than that, okay, it involves the study of how these devices communicate and exchange information using protocols and technologies to facilitate this interaction. So using the protocols and technologies, meaning that the um, everything that communicates, it doesn't matter whether it could be technology, it could be animals, it could be nature, it could be people, everything has their own language that they can understand. For example, I'm explaining to you in English, so that's the protocol that we agree to talk. So in the networking world, it's the same. So when computers are talking to each other, they decide, okay, we're gonna talk in this language. Okay, we're gonna work on this technology, because you cannot, if you cannot agree on the same things that you wanna work on, then it's probably not, you're not gonna make it together. So using the protocols, meaning just agreeing to use one language that both sides can understand, or a lot of sides can understand, and come together on that. Networking encompasses a wide range of topics, including hardware, software, and the underlying principles that govern network operations. So, as I said, networking sits on top of a lot of. Okay, now I will give you. Okay, if you take a look to the spider, for example, think of the main body of the spider as networking, and the other legs as okay, I don't think it will be a nice example, but let's say uh, draw, and I'm gonna draw something. Okay, let's say this is networking, right? That's networking, and networking has a lot of nodes, branches, so to say, which connects a lot of computers. Let's consider those circles. It's not exactly the circle, but think of that as circle, and consider those circles as computers, and the networking part sits on the center, which centralizes all the computers and connects them together. And those thing handles basically how the information goes. Let's say you are I don't know, Alan, right? And you have a friend John, and you want to send a message to the John. So basically when you send a message, so networking handles those okay, it it this message comes from Alan, and he wants to send to the John, let's say. He basically having a postman, and let's say two, it's gonna be probably, not probably, in our example, of course, obviously Alan, and I don't think it's Alan. Okay, sorry for that. It's gonna be John. So, and from is gonna be John. So no, not John again. Sorry, guys, for my drawing. Okay, it's gonna be Alan. So the whole idea of networking is when to, and how to, and whom, or from who or to whom. the part which is the networking part is knowing when to handle those cases. And yeah, it those consider those threads as physical cables, which is undersea cables. Now I'm going to explain undersea cables. So it is physically connected, as you can see here. And these are all the cables under the sea, which connects the continents, which connects the countries to each other, so eventually making the networking worldwide possible. So but as we seen in our daily life, we do not really connect to each other with the cables, because it could be like silly, right? Because on your mobile phone, which is also a sort of computer, uh, and imagine you could always plug in your cable and then go outside, which is not that practical in our daily life. So what that means is that those cables are comes to the some part of the country, to the to in each continent, and then from that the in different parts of the countries will have their antenna. If you have noticed it, like um, ISP providers, which is internet service providers, like T-Mobile, the popular ones, or Verizon, or I don't know, Beeline, or O-Mobile in Central Asia, or Megaphone. Those companies have their like antennas, which is in the middle of the city most of the time, or like next to city, and which we call I don't know, to be honest, how to call it in English, but it basically the antenna, big antenna, which is you know, with the height of I don't know, maybe 30 meters or 50 meters, and they just basically allows us to connect to the internet without us carrying the cable with us. Uh, so basically, but at its core, those antennas with really high height are also physically connected to those cables. So eventually these cables, let's say one cable came to the, I don't know, let's say Germany, right? And Germany, and those physical cables connected to, let's say, that mobile antenna, and those antenna just provides all the internet to the mobile and the computers users in within the Germany, so that they cannot carry the physical cables to the every mobile or computer, which makes our world really chaotic. Okay, so that's the whole idea. The big brain, the smart move in here is the idea of but how they are connected. That the thing comes to the radio waves, because those antennas are basically works with the radio waves. So it basically gets all the information about from your phone, let's say in the case of our Alan's case, from Alan's phone to the John's, let's say, I don't know, let's say John is in US, right? And with his mobile phone as well, and so it takes the radio waves from Alan's phone, and then sends back from the physical cable from the ISP, internet service provider antenna, and goes to the John's phone. So the smart thing about is that it exactly knows from who and to whom. That's the smart part of the networking. And you basically pay for those internet service providers monthly subscription when you pay for your internet, for your Wi-Fi router in your apartment or in your house. You are basically paying for those companies so that they can provide you a better experience when it comes to connecting to the world of networking, to the other computers, other devices, to the other people. And it makes our life really, really, really easy and really, really efficient, because imagine, as you can see here, imagine connecting to do that much cables physically, and we have roughly around 10 billion people in the world currently, which makes it almost impossible. And it's not about the like device per person, because me myself have, I don't know, 3 devices, which counts as 3 computers. So I have mobile, I have 2 other computers, which is basically makes me 3 different person. And then eventually I should carry the 3 different cables in order to connect each computer uh, to the internet. So thanks to the those internet providers, as I have explained, uh, that providing us smoother networking experience. And yeah, that's the basically whole idea of networking. So there is no magic, everything is connected physically. And yeah, the idea that in the general term, in the higher level, everything is physically connected, as we have seen in this example. But in the smaller level, let's say, in the case of country levels, let's say, I don't know, maybe from Middle East to the, let's say, Kazakhstan, as you can see, there is no physical cable, but those are from nearest the neighbor countries. For example, I don't know, maybe comes from Turkmenistan, or I don't know, from Saudi Arabia to Kazakhstan, and to Mongolia from, I don't know, maybe Tokyo, or I don't Tokyo, okay, Japan, or South Korea side of things. So because there's no point to um, physically connecting to the each country, because they can take the internet from the neighbor parts. There are agreements in the worldwide, so they cannot the other countries cannot stop providing the internet, because let's say Uzbekistan and Saudi Arabia had political issues, and Saudi decided to cut the internet for the Uzbekistan. That's not the case, because they can take the internet from the Turkmenistan, or let's say from the India or Nepal side. So there are several alternatives for each country. So there is no such a thing that one country can just block the other country just because of they are having political issue. So that's how the general picture works. And even though, as I said, even though when it's reached to the country, let's say in the example of, I don't know, let's take the India, but let's say how the middle of the India gets connected to the internet. It's, as I said, thanks to those mobile antennas, um, as you can see here, and which basically tracks and which keeps track of the with the devices, each device via radio waves. That's the whole idea. So in the okay, let's say this in a way. In the smaller picture, you basically get the antenna from the service providers or Wi-Fi routers, and then you pay for your subscription, and they are the one physically connected to those cables. It's usually under the earth, and so that, or it could be like physical threads or physical lines you could see on the streets, which basically mobile cables or internet cables, but people do not recognize most of the time. they are actually physically connected, but in a smaller picture, since there are millions of people, and with each one nowadays having more than one device, which counts as more than one computer, which makes really not that practical having physically connected each device to the networking. So that's why in the smaller picture it works via the radio waves, as I have repeatedly said several times. Yeah, guys, as I said, guys, I'm explaining those things on the fly. I do not have anything prepared. I'm just making things up on the fly, even the examples. And yeah, and I might say things repeatedly and explain the same thing over and over, maybe repetitive words. So as I said, please, please, don't get me wrong on that. And yeah, the whole idea of me talking that by the time so that I can get better at explaining the things without scripts, without anything prepared beforehand, without any slides and without any preparation. So eventually, when you are well prepared, which makes it much more better. And that's basically what the networking is. And probably I don't know how much, I do not know how much I've been talking on that, but as I see that it's roughly, I don't know, more than 20 minutes already. Okay, anyways, yeah, it's probably gonna be, I don't know, up to an hour, or I don't know, because those things are takes time to understand, and just don't get demotivated just because you are not getting what I'm talking, because as I said, those things maybe take months, or I don't know, maybe years to understand for someone who has never touched or I don't know, seen about these things. So that's why do not worry. So do not worry by thinking that you didn't understand. It takes time, and it takes time and some practice. So if you have time, just to look at those undersea cables and how they are connected to each continent and how they usually function. Yeah, I don't know, to be honest. Like, should I should I explain more deeper on the networking part, because that's the general picture that you should be understanding about the networking. And other than that, uh, there are detailed explanation about each step of the networking. Like it doesn't automatically get from here and here, because there are a lot of things that are happening. So basically those cables are carrying the binary data, not necessarily the actual message. Okay, let's say uh, Alan said, I don't know, maybe hi to the John, but it doesn't mean that the message hi goes physically via cables to the John, and then John receives the hi. Okay, because the cable itself cannot just carry the text that we see in our life. Basically it carries the binary data, which is ones and zeros, which eventually makes up those text hi when the John receives. And it's not necessarily that always without any problem, like constantly John receives the hi message, because there will be some traffic issues. And it's funny thing that sometimes the sharks, or I don't know, maybe whales just cut those cables, and then in some part of the countries, people just gets blocked from connecting to the internet. Yeah, but for such cases, there are alternatives. There is no just one cable connected to one country, and if shark gets bitten that cable, so there is no internet for that country. It doesn't work like that. So there are several alternatives. Even though sharks just cut the cable, other alternatives gets chosen and then delivers the data. And there are people, there are organizations that are handling, that usually manages all those undersea cables, as you have seen this example what I was mentioning. And yeah, in this sort of things, basically that's the cables that are carrying all your data. And yeah, as I have said, it's not necessarily it's basically just carries the light. Light meaning 1 and 0. How come light can be 1 and 0? Okay, as I said, I don't wanna get back to the binary once again, because it's gonna be long lecture. And okay, in shortly, I would say ones and zeros, meaning that if the lights is on, it's gonna be 1, and if it's off, let's consider this picture as off, it's gonna be 0. So um, if you know about the Morse code, you probably know what that means. It's basically Morse code is the uh, ancient ancient version of binary. If I if I'm not mistaken, that's the correct explanation. Let's say if you turn on the flash, and then let's say if you turn on the flash and then hold for some time, let's say 1 second, it's gonna be A. And then let's say if you turn on the flash for 1 second and then 3 times turn on and turn off, it's B. And then with such frequent turning off and holding the light, you just basically explaining what you are talking about to the other end, because um, uh, yeah, that's how you communicate with someone. Let's say you are in the middle of the sea or ocean and you want to send to the other people, to the other people, send a message, then you would probably do sort of massive flashlights to your teammates by turning on and off and holding. So basically they will type on the paper what you are saying by those sort of things. Okay, if for someone who sees for the first time Morse code, it could be not that practical. Okay, how can you read this? Okay, those guys are well trained on that, so that's why they understand. And back to our example, that's the same thing in the okay. Okay, in our example, because in our example, as I said, if the light is on, the light is on, it basically shows 1. If it's off, it's gonna show you the 0. Those cables, those undersea cables, basically works the same way as I explained in the Morse code example. And but okay, how come can they explain the things? Let's say in the Morse code example, let's say you turn on and off and turn on hold for, I don't know, maybe 2 or 3 seconds, so it means A. So in the computers they have programmed the binary code that if the light comes and light turns off and then light gets hold for some seconds, I don't know, 2 or 3 seconds, then it's gonna be A, and then we draw in the screen of the computer A, so it's gonna be A. So, and these type of things in the for other characters and for numbers and for symbols, as I said, guys, just I am trying not to get too dive into the technical parts, because it might not make sense for you right now. As I said, since I do not have more of like a preparation on that, maybe I'm not explaining really well, but that's the whole idea. I hope you get the idea, even the general idea, even the general picture on how things work, and what the networking is, and how the binary works. Okay, at the end we get back to the binary again. The reason why I didn't want to explain is that because it requires not on the fly explanation, because not requires, but it it's stupid. It is silly to explain the binary on the fly, because you should have well preparation on that, because it might not make sense. Okay, after, let's say, after several years of experience and expertise in the computer science, maybe I'm eventually able to explain the binary in while without any preparation, without any script on my screen. Well, when it comes to networking part, since it's pretty intuitive and self-explanatory, so that it's easy for me just to look for the things and then explain on the fly, and come up with the slice dynamically, rather than binary itself, because it's quite complicated topic. It doesn't make sense for someone who is not familiar with the computer terms. And yeah, what else? Okay, let's finish our concept on network, explanation on networking. So networking encompasses a wide range of topics, including hardware. Hardware basically means the physical computer that you see in your monitor, or your actual computer in keyboard. That's the hardware, which is the physical thing that you can see. What about the software? Software is an application inside your computers. Let's say you have an Android or your iPhone, and you have inside, I don't know how, let's say Uber taxi, right? That's the software, which is the application inside the hardware. Your hardware is your actual mobile, physical mobile. In the example of networking, it is the same thing. It doesn't mean like the physical cables, because there should be some application inside this networking that handles all those routes and all those messages to the appropriate people. Because let's say Alan send a message to the John, but if there is no logic, there is just a physical cables, how it should know, how those physical cables should know that it's exactly for John. There should be some logic, there should be some application. So that's why networking is not about just the physical cables connected under the sea and then under the earth, in the specific country. It is about the software as well. There is some application. There are some application like Uber taxi. Those Uber application is just built in a way that connects people with the taxi online without without any physical communication with the taxi drivers. It's the same thing. So it's the same thing. There is an application, let's say networking application. Is not the same application, of course, in the computer. Then you could just play around. It's more complicated application, which handles like billions of those routes and messages throughout the world. Someone is uploading video on YouTube as a content creator, someone uploading to Instagram, and someone is weaving, and someone is commenting on someone is downloading the games, someone is playing the games, and those sort of things. A lot of billion, even trillions of things, data are exchanging daily, even per second. So that's why there is a really complex application, and like really application, not a physical thing, not just a physical thing. So it's both physical and actual application. Yeah, it's just I don't know if you heard, it's just my alarm goes off because it's early morning. It's 4:32 a.m. Yeah, because I'm pretty night shift, night owl. Yeah, let's back to our concept. Yep, there are key aspects of computer networking communication protocol. That's the important thing, which is the language that those massive big number of computers. When I say computer, it doesn't necessarily mean like computer you see MacBook or Windows. It's just mobile phone and the smart fridge and your, I don't know, Apple Watch or Mi Watch, or those sort of things can be considered as computers as well, because they are itself is a computer. And yeah, communication protocol, they decide to talk in one language so that they can understand each other. Yeah, networking relies on standardized rules protocols to ensure the devices can understand and exchange information correctly. Examples include TCP, NIP for internet communication, and HTTP for web browsers. So when you are browsing the web, if you take a look, there is an HTTP always, but it's not shown when you hover over and select the text specifically. You see the HTTP, that's the language, the browser, so my current browser, and the one that, which is the Google server, decided, okay, we will be talking in this language, which is HTTPS. Let's say imaginary language, I don't know, maybe TT and YP, let's say Google, and then my browser decided to speak on this language, then TTYP would be selected as protocol for computers to talk. And hardware, as I said, physical cables, because without physical cables there wouldn't be connecting, because the earth is really big, and then there's no I don't know, maybe antennas cannot quite differentiate the radio waves, because of a lot of distance between the continents, and then there is massive oceans. And yeah, okay, that's why physical cables are necessary. And networking involves hardware like routers, switches, and network interface cards, which are essential for connecting devices and managing network. Okay, yeah, software, as I said, there is an application, there is an app, let's say in short, or an application which really knows how to handle those devices without any problem, because you want your email to be sent to the exact person that you want to receive. Yeah, networking software such as operating system drivers and networking management tools enables the implementation and management of network functionality. Okay, network architectures. Different network topologies such as LAN, local area network, and WAN, wide area network, are used to organize and connect devices based on their geographic location and needs. It's basically the same idea would not work everywhere, because the earth is different. In some parts earth there are deserts, right? And some part of the earth there are massive mountains, so you would need to somehow work around uh, for such cases, because one solution wouldn't work for everywhere, every part of the earth. So that's why we need different types of networking architectures. This one there's no one fit for all types of all types of cases in our world. Security networking involves implementing security measures to protect data and prevent unauthorized access, including firewalls, encryption, and the access control mechanism. That's where the things get interesting, because the hackers can really hack the things and then steal your data. For example, in the case of our example, Alan wants to send a message, let's say secret message, to the John, but someone, let's say when Alan sent the secret message to the John via those cables, someone hacks the application in the networking part, and then let's say here hacker, and then receive those message, sees the message and then redirects that Alan's message to himself. And that's where the hacking things goes. It basically happens in this part. People hack each other while sending different types of data. Just hackers get into this part of the app and then just redirects the message, or even though without redirecting it, it just knows that this message was sent to the John and knows about this and takes the further action. So it is really crucial when it comes to the security part. And then not last but not least, applications. Networking enables various applications such as email, file sharing, web browsing, and online gaming by facilitating the exchange of data between devices. As I have said, it's not always the message, like static message via the WhatsApp or Telegram. Oh, hi, how are you? It's not always the text-based. It's like it could be an email, it could be a file sharing when you are sharing the video or reels or YouTube shorts with your friend. You are basically just sharing the files, not the raw text. And it could be web browsing, as I'm now doing. I'm just browsing, and online gaming. You could be playing online games with others, let's say PUBG with your friends, and you are basically just connecting your mobile phones, which can be counted as small computers, and then doing your part. And yeah, by facilitating the exchange of data between devices. As I have said, yeah, guys, it's not necessarily always raw text. It could be anything that see it as what you can do on the internet today can be counted as of type of the application itself, as different application. Yeah, basically that's it, guys. That's it. I know it's kind of too long, kind of overwhelming, but yeah, maybe with some preparation and some script that would, I don't know, we could double cut the half of the explanation and the half of the phrases that I'm using, and without any repetition. But that's the whole idea. You got me. And there are tons of like really useful source of information that you could find on the internet, but the main idea is me myself just practicing the way how I explain the things to the others. So it's not really the explanation focused, but rather than practicing the explanation focused. So that's how I would state that. Yeah, that is basically it. And probably okay, no, probably guys, in the next sections I will be talking about OSI models, which is the part where we have networking, and then how from those cables goes to our mobiles. Okay, I explain it, but it's general picture. But as I said, how those gaming things, and how about music, how about pictures, how they are sent. So we will be diving a little bit deeper on those things, and hopefully eventually those magic things like networking and then internet makes more sense, and eventually you prevent yourself from different sorts of attacks from hackers, and be more be more, I don't know, hygienic on your digital life. Yeah, I'm summing up from here, and I hope you enjoyed the part, and see you next time.